Alright, so we're still in 8.3. We're just going to be working with a little bit more of these. Page 633 it looks like. Alright, this first one. I've got three fractions. I'm not going to be able to cross multiply. So I need to factor first so I can find their least common denominator. So I'm going to go 3 over x minus 1 plus 2 over 5x plus 1 equals negative 3 over, this is going to be difference of squares, so it's x minus 1, x plus 1. And what I'm going to do is I'm going to do the book way. I'm going to multiply by the least common denominator. Actually, we'll do it the other way first. I'll multiply everything. So the least common denominator is going to be 5x plus 1, x minus 1. So I'm going to multiply whatever it's left with. So what does this need? This needs a 5 and an x plus 1. This needs a 5 and an x plus 1. This guy right here needs a x minus 1, an x minus 1. This guy right here needs a just a 5. And so I know that all these denominators are going to be the same. So since I know when I do this, it's going to make all the denominators the same, I'm just going to worry about the tops right now. I know that my bottoms are going to be the same, so I'm only going to worry about the top. I'm going to distribute this, and so it becomes 5x plus 5. And then I'm going to distribute the 3, and I'm going to get 15x plus 15. Now this is a plus sign, so no big deals here, so I can just distribute plus 2x minus 2 equals negative 15. I'm going to set this, there's only one x in this. There's only, see, this is x and this is just x. There's no x squared, there's only one x with a power of something. So I can actually, I don't have to set this equal to 0. I can get everything away from the x and solve for it. So when I go through this, I'm going to combine like terms and I'm going to get 17x plus 13 equals negative 15. Minus 13, minus 13, 17x equals 28. And actually, before I do this, I should have done something. It's my fault. I keep forgetting to talk about the restrictions. We need to talk about restrictions here. X cannot equal, what would be on the denominator? It would either be positive or negative 1. That's the only things that make it 0. So positive and negative 1 are my only restrictions. I would then divide by 17, this would be a negative, divide by 17, and my answer would be x equals negative 28 over 17. And yes, I should check that, but since it's such a nasty number, I'm not going to go through that, and I probably would not give you something like that on the test. I would not give you a nasty number like that and expect you to check it in the amount of time that we have. So hopefully you understood that. Now let's go through the rest of these, a couple more. This one, since there's only two fractions, I would cross multiply it. And so we get 8 x minus 2 equals 9 x minus 5. And distribute. 8x minus 16 equals 9x minus 45. Again, x is to only one power, so I would combine those x's. I don't have to set it equal to 0. I can get everything away from x. But you'll see what I'm talking about hopefully in a little bit. I'm going to minus the 8x so that I keep my x positive. Negative 16 equals x minus 45 plus 45 plus 45. And I get that x equals 29. Alright, so let's try this one. I'm going to try and multiply this by the least common denominator, which my least common denominator is, this is over 1, so my least common denominator is x. So if I make them all have x, I'd have to multiply, if I multiply everything by x, basically what it turns out to be is this already has it, so I'd have times this by x, and I'd times this by x, and so I end up with 5 equals 25x plus 5. So when I minus 5, I get 0 equals 25x. But I need to be careful because right here there's a restriction that says x is not allowed to equal 0. But when I divide by 25, I divide by 25, my only solution that I come up with is x equals 0, which is part of my restriction. So I say nope, and that doesn't work. So this answer is actually, there is no solution to this problem. Alright, last one I'm going to basically do, and then when we come back in class, I'm going to have you do the rest of these in class, the ones that we didn't do. So in class, you're going to do A, B, C, D. So I think we're going to do this last one, and then I'll let you try some on your own on Monday again. The more you do these on your own, the better it's going to be, but the process is still the same. So we are going to attempt to do K. Let's do K. So when we go to do this guy, we realize this is not a fraction, so I can make a fraction over 1, the least common denominator. If I factor this, this is x plus 1, x minus 1, so it's a difference of squares. So my least common denominator is x plus 1, x minus 1. So I have to times everything. This guy needs to get multiplied by a. It's missing an x plus 1. This guy needs the whole thing, x plus 1, x minus 1. And so when I do that, I get left with on the top x plus 3. Distribute this guy, so it becomes a minus 2x squared. Distribute this guy, you get a minus 2x, and that equals x squared minus 1. I know that's going to turn to x minus that because it's a difference of squares. So actually, because of this guy right here, because I know that's going to be my leading coefficient for when I try to factor, I'm actually going to move all my stuff over here because I want this thing to be positive. Remember, you're allowed to move it. Yes, technically could I move this stuff over here, but if I did that, I would end up with a negative x squared, and I am trying to set myself up to be easiest. So I'm going to move everything to the other side. And while I do that, so this and this can combine like terms, so let's do that first. So it would be negative 2x squared. This and this becomes a negative x plus 3 equals x squared minus 1. So I'm going to add 2x squared. That would combine right here. I'm going to add x, which doesn't combine with anything, so it's just going to be plus x, and I'm going to minus 3. And so I end up with 0 equals 3x squared plus x minus 4. And then the rest of this problem is algebra 1. Before I do that, I should have talked about restrictions. I know that x cannot equal 1 plus or minus 1. So I go, okay, the long way. Two numbers that multiply to 12, but different numbers, different signs, so they're going to subtract to a 1. That's 4 and 3. I personally always put the negative, since they're different signs, I put the negative one first. It makes it easier for me. So I get 3x squared. It's going to be minus 3x plus 4x and a minus 4. That's the factoring. Factor by grouping, and I get 0 equals 3x is what they have in common, left with x minus 1. A 4 is what they have in common, left with x minus 1. This factors out into 0 equals 3x. Actually, do this way. What do they have in common? X minus 1. What's left over? 3x plus 4. That means my roots. When I set this one equal to 0, I get x equals 1. When I set this equal to 0, I can't see it right away, so I set it equal to 0. I minus 4, I minus 4. 3x equals negative 4, divide by 3, divide by 3. X equals negative 4/3. And I get, my answer is x equals negative 4/3 or 1, but I know that it's not allowed to be 1 because of my restrictions that were from right here, which my denominators said, nope, that's not allowed to be good, so I know it can't be that, so my only answer is x equals negative 4/3. And again, you should check that solution. You should take and plug that back into my originals I will be hesitant to give you some number like that, but technically you should be able to start using numbers and plugging in with fractions. On a test, I won't give you something like that again, just because I'm trying to keep it within time. But hopefully that gives you some more examples. Like I said in class, we're going to finish the rest of these boxes that we didn't do. And then we will work on 8.4. And our test will be coming up soon, just because I don't think I said that in class. There's only 4 sections in this, so it's 8, 1, 2, 3, and 4. So we'll be having a test probably towards the Thursday of next week. All right. Hopefully you guys have a good weekend, and I will see you on Monday.